Hello everyone. In this video, we are going to push forward and talk about four functions: apply map, and where. And at the end, we are going to see that oftentimes we can get away with one, at most two of these functions. All right. So let's start this imaginary example where I'm creating 30 random temperatures between -50 and 50. And I created list for index values. I call them day underscore 1 to 10. And I create three column values: city 1, city 2, city 3. I've ran that. So let me run this one as well. Oh, let me run this again. All right. And this one. There we go. What I have here is a data frame. And by the way, I want you to notice that I pass index inside data frame function, index values, column equal to column values, and show me data frame. And I have this data frame, some extreme values, -50, -28, 45, right? But it's okay. This serves our purpose. In the past, we have used Boolean indexing mostly for filtering out some of these rows. All right. What do I mean by that? I'm going to say df, give me those rows that df data df that city one is less than city one is less than minus 20. I want to see -25. Let's say which days was really cold for in city one. All right. And it's going to say day 4, 5, and 7 temperatures were less than -25. Well, this is great. We use this a lot, Boolean indexing. But what you notice is that Boolean indexing removes the other rows, at least in this display. Right? It says, you know what, day 4, 5, and 7 satisfies the condition you gave me, and the other rows, I'm not going to show it to you. Again, as I said, we use this a lot, but sometimes we need to keep the whole data frame and replace, do some the operations on each value or each column, or replace some values with some other values. And that happens quite often. I'm going to start with something very, very simple. All right. Let's call df one more time. That is my data frame. I'm going to say, you know what, np data absolute value, give me absolute value of temperatures, right? Absolute value of df. You can do that. You can call those universal functions, abs, absolute value on data frame, and sure enough, it is going to give you those absolute values. Or you can, let's call df one more time. Df hasn't changed. All right. I can say, you know what, df data city, give me np data square root of df data city 1. All right. Just give me I'm sorry, not square root. I don't know why I keep going at absolute value of just temperature, absolute value of temperatures in city 1. And sure enough, you are going to get that as a series. All right. If you want to replace this with in this data frame, if you look at data frame, those temperatures haven't changed, right? This is just a view. If you want to replace that, you have to say df dot city1 is equal to np dot. Let me write it. It's fine. Df dot city1 is equal to np dot absolute value of df dot city1. All right. If you do that, then it is going to permanently change that column. All right. And it's okay. Let's look at data frame, because we can always go back and recreate that data frame. I don't have any negative values here. Right. They all are absolute value. This is one way to just perform operations on one column without removing some of these rows. All right, this is one way. Another way of doing that is I'm going to go back and create a data frame one more time. All right, and that is 2 and 3. I'm going to something that probably sometimes I discuss in classes, sometimes we don't. There is a magic function called load2. It is going to load that row, that column 2. I'm going to run it, and then I'm going to say, you know what, load 3 as well. Load 3 as well, and run it. There we go. Now we have new temperatures. Instead of doing this, instead of calling, where is that? Instead of calling doing this, what we can do, we can use apply function. How does that work? Apply, oftentimes what it does, it accepts a function and it performs the output of that function or that function on each of the values in that series. All right, let's just look at let's look at it. All right, I'm going to say df.apply, right? If I put question mark in front of it and I want you to get used to reading this and understanding how this works, it says applies a function along an axis of a data frame. But if I say, df data city underscore one, now I want to use apply function for a series. Let me run this and see what I'm going to get. Remember, this doc string talks about data frame. But if I run this, it's going to say invoke function on values of series, right? It recognizes that this user is passing a series, so I need to adjust my doc string accordingly, all right? Which is pretty cool for pandas. Now, anyways, let's do this. df.city_1.apply what? Now I have to pass some function. Why? Because it says, apply accepts a function. Forget about the other arguments. Most of the time we are not going to use them, but apply what? Well, I haven't defined a function. Well, remember we had on-the-go functions called lambda functions, right? Lambda function is going to accept x and return np dot absolute value of x, all right? If I run this, what is going to happen is that in this new data frame of random numbers that I have here, only column of city 1 is going to turn to absolute value, all right? And sure enough, it gives me that, right? It's a series with column values. Where is that? 12, 12, 39, 2, 12, 39, 2. Again, if I want to permanently change that, I have to write df.city_1, this one. You are familiar with this. df.city_1 is equal to that, all right? And if I run that, it's going to go through. And now yet another way of doing same thing is, let me call df one more time. Another way of doing same thing is defining a function, all right? Let's go and define a function called def abs calc. ABS calculator is going to accept x and return what? Return np data abs of x. Well, do I have to always use numpy functions? Absolutely not. You can write anything here. You can say, return x to the power of 4. You can do that as well. We are just using that as an example, all right? np data abs of x, right? Now that I define this function, I can say df data city_1. Was it city? Yes, city_1 dot apply what? Apply abs calc, all right? And sure, it is going to give you the same thing, right? The difference between what I have here, let me remove this bit. What I have here is a passing lambda function. I didn't give that function any name because lambda functions are functions that they are short one-liners. I don't even give them a name, all right? But here I define the function and pass that function to apply function. Keep this in mind that whenever I pass, so far we have used functions, and whenever we have used function, we have put parentheses in front of it. But here, this is the first time we are not doing that. And the reason it works is that pandas looks at this and says, user wants me to call this function. All user needs to do is give me the function's name, and I'm going to use apply function to call the function, all right? And that's why you don't need to put these parentheses in front of this function. As a matter of fact, if as you can see, you cannot put parentheses in front of it, otherwise you are going to get an error. Now, something to be mindful of, generally speaking, what happens is that when you call an apply function, typically what happens is that this function is going to be called for every value in column of city_1. Again, there are some improvements in that area, but typically this is what happens. All right. And if in this case it doesn't matter because you only have 10 values, but what if you have 1 billion values or 5 million values? Then you are going to have that calling function that many times, and it can get very, very slow. All right. Something to be mindful of, and that's why I personally I try to avoid apply function as much as possible. Sometimes it's pretty handy, but especially with larger data sets, I try to avoid it as much as possible. Now, let's go ahead and run that on whole data frame. Let's see how it's going to work. All right, say df dot apply, because right now I'm applying it only to city_1. That apply what? Apply ABS calc. All right, let's see if it's going to work. So if this works, it is going to give me absolute value of all of these values, right? Let me call it, and there you go. Right, it says, you know what, I can I can do that. Well, let's call df one more time, df one more time, and df hasn't changed, right? Again, this is just a view. Sometimes especially if let me go down here. All right, df dot apply what? Lambda x and return np dot abs of x, right? And you see that it works with on a data frame with lambda with lambda function as well. Now this is the same more or less. Apply, let me put this right here. Apply is more or less the same with map, more or less the same with apply map. You see the names are pretty much similar, right? Apply map. So let's run them and see how it works. Everyone, for the sake of keeping this video short, and it has already been 12 minutes, for the sake of keeping this video short, I'm not going to discuss this more, but let me just put it this way. One of these functions, map, apply map, one of them is just for series. The other one is just for data frames, and one of them works in all series and data frames, but you got to be careful how you pass series and data frames to it. For example, let me try df data map of not what was the function's name? Where are you? ABS calc. All right, ABS calc. It is not going to give you. It is not going to work. If I say apply map, it is going to work. See the map, if I look at map, and I already answered the question and made the video longer, but it's okay. If I put a map here, df.map not defined. All right, so that map function df city_1 dot map, see now it works. All right, let me map values of a series according to an input mapping or function. All right, it works only on series. Anyways, so these three, out of these three, all you need to do is apply, and oftentimes even this apply is not a good idea to use. In the next video, I was not planning on having such a long video just for these 4 functions. In the next video, I'm going to talk about where function.